Okay, so have a think about what we have learned last lesson. Well, last lesson we learned what is differentiability. Okay, so what is differentiable? The last question we do is that one. When a function is differentiable, it must be a smooth continuous graph, then it's differentiable. So in order to say what is the differentiable, let's say what is not differentiable. First of all, if a function is not continuous at that point it's definitely not differentiable. Second, if you have n points, okay, n points are not differentiable for sure, okay. Doesn't matter you have a closed circle n points or open circle n points, you can't differentiate that point, okay. And number 3 is, if a graph is connected, but is not same gradient on each side of the function. Well, say I have fx and gx, they're connected at x equals to 2. So f-2 and g-2 are not giving you the same value. Then we cannot differentiate that. Okay, that is differentiability. So 3 cases that you cannot differentiate the graph. Okay, 3 situations you cannot differentiate that point. So I think what we learned so far in that chapter will belong to one chapter, and what we'll learn today, like page 9. In year 12 will be a separate chapter. Okay, so it's not really belongs to differentiation, it's anti-differentiation. But like because we only learn polynomial, how to differentiate polynomials, well, not exactly polynomials, it's x to the power of n, okay? We learn how to differentiate x to the power of n. Therefore, we will learn how to anti-differentiate that. So it's going in reversed, okay? So I have fx into f dash x, that's called differentiation. Then if I have f dash x, I'm trying to go back to fx, that is anti-differentiation. Okay, first of all, I want to ask you, I have fx equals to 2x squared plus 1. Gx equals to 2x squared minus 1. Hx equals to 2x squared plus 100. Can you tell me what are the differentiate function for them? Like for those 3 functions. Okay, fx equals to 2x plus 1, gx equals to 2x squared minus 1, and hx equals to 2x squared plus 1, plus 100. What you can tell me? Like, it must be something special, and then I ask you to do that. What you can find after you differentiate all of that? You have the same gradient function, okay? You have the same dy dx or h dash x, f dash x, and g dash x. They all will be 4x, right? 4x. Like all the differential function is 4x. All the gradient is 4x. Okay, what that tells us? Okay, all the dy dx here will give me 4x. 2 times 2x, okay, 4x. Okay. So what is anti-differentiation? Anti-differentiation is using the gradient function to find your original function. Okay, now according to what we write, what do you think the 4x, if you do a reverse action, which one you will come, which one you will get? Like you come in from 3 functions, all going to a same gradient function. Okay, when the same gradient function trying to do a reverse action going back, which one you will get? You can get any, right? Like this one satisfied, fx satisfied dy dx, gx satisfied that, hx, they can all become pairs. Okay, if the dy dx be anti-differentiate, I want to go back, I can get all of them. Well, 3 of them, they're all satisfied because they are all pairs. So, which tells us the constant. I can't make sure the constant. Okay. Okay, where are we up to? We said we anti-different. We can only get the 2x squared part, right? The 2x squared part, like everyone got that. But we don't know the constant. Well, I can be plus 1. The original can be plus 1, can be minus 1, can be plus 100, even can be plus 0, like plus nothing. I can't tell. Because when we differentiate that, the constant just purely disappears. Doesn't matter what constant you have. So when you do differentiation, so one fx will only map to one f dash x. But when you anti-diff f dash x, you can have many functions which satisfy the anti-differentiation. Okay, so that's the point I want to make here. So it seems like, well, x to the power of n plus c, if you differentiate that, what you get is n times x to the power of n minus 1. Okay, then when you anti-diff that back, when you anti that back, there's a plus c, but you don't know what is that c value. Okay, you don't know what is that c value. So this c can be 1, can be 2, can be 3, like, can be 100. So what is it? Like, I can't tell this number here. So that's the thing you need to be aware of for anti-differentiation. When you're trying to differentiate something, yes, there will be a unit function. But when you're trying to anti-diff something, there's more than one functions. Okay, you need to represent this like it's not a unique thing. Okay, it's not a unique thing. So let's just have a think. When you do differentiation, what you have done? You have first times the power right in the front, like the n will times to the front. And what you have done, you subtract the power by 1. That's what you have done for differentiation. Then for anti-differentiation, that's easy. You just do the reverse action. Okay, so then you plus 1 first to recover the power. And then you will divide the number, you have plus 1. You divide the power, you have plus 1, that power. You will divide that power. Because you do a totally reverse action. You bring the power down and then subtract the power by 1. So to recover this process, you will bring the power up by 1 and then divide that. So that's the reverse action. So the formula will be here. Okay, formula will be here. If you have n, you will go n plus 1 first, and then you will divide by n plus 1. Okay. If you have n here, you go n plus 1 first, and then you divide by n plus 1. So a constant a, right. Not say the constant a thing. Just look at the c. This c is not a unique function because there is still a number I can't decide what is it. Well, if give me 1 point on the original graph, yes, I can decide what is it. But without giving me that, I will just leave the plus c at the back to tell people, yes, there is something I don't really know. So there will be a constant. I just don't know what is that constant will be. Well, c can be anything, can be 0. Well, there might be no constant at all. Or it might be have a 4, have a 5. So it depends. It depends on, maybe give me a point, I can decide it. Okay? So I must have this plus c. So the most important thing for anti-diff is this plus c. I can never really left that plus c. So that plus c is worth 1 mark. Okay? Year 12 sec, that's 1 mark. Okay, in your answer. You can't miss this plus c. Anytime you anti-diff something, you will leave that. You will leave that plus c as part of your answer. And for a, if you just have a constant a, what you can do? Well, this sign is anti-diff sign. Well, I haven't really talked about that, but I hope you know that. So you put this. Well, that's in total 2 things make the anti-diff. It's the instruction for anti-diff. Whatever you put in the middle is you want to anti-diff treat this as f dash x. So this function will be f dash x. You anti-diff that function and then you want to go back to get the fx function. Okay, so that's the meaning for anti-diff. So the sign is that like a big S and then dx 2 parts make the anti-diff instruction. So anything you put in between is I want to do the reverse action to the middle function. Okay? Okay, and then we know that like ax plus b, will differentiate that, will give you a. So you anti-diff a, you will get ax plus c. Okay, you get ax plus c. You anti-diff a constant. It's just same as you put like x, put the x, okay, after that. Okay, and then we have some general formulas. If you have two functions plus together, you antidiff two functions plus together is same as you antidiff separately. Well, you can antidiff them separately. You can antidiff fx first and then gx first and then add them together. So subtraction is the same. You can antidiff them separately and then subtract them. The last one is quite important, is if you have a constant times with your x, you can bring that constant outside from the antidiff. Okay, it's not a plus, it can't be a plus a constant, it must be times a constant. For example, 3x to the power of 2, if you want to antidiff that one, it will be the same as you put 3 outside of that one. I don't really care what is that constant. That constant just always times together with the function. So I can bring that outside. Okay, I can bring that outside. But it doesn't really matter. You can leave it inside. It will be the same. Okay, so let's have a look. This type of integral is called indefinite integral. Okay, indefinite integral. Later on in year 12, I'm not sure if you will learn this year, if you have time or not. But next year we'll definitely learn another thing. It's called definite integral. Okay, this is called indefinite integral. Later we'll learn a definite integral. So it's different meaning. Okay. This one you can treat as I have f dash x function and I want to find the anti-differential, like the fx function. By using the gradient function, I want to find the original function. That's the meaning. Next year, what we learn for definite integral is a totally different meaning. It's nothing to do with the gradient and the fx. It's more about the area under the curve. Well, that's a totally two different meanings for anti-diff. But like we just learned this now. It's called indefinite integral. And then what is a general anti-derivative means? That means you need to plus c at the back. General, like you want a general solution. Like circular functions, think about general solution. You have the k times period, and k can change. So in this one, it's the same. Well, c is just part of your general solution. You need to leave the c there because you don't know what the constant will be. So c is there to tell people, well, c can be 1, can be 2, can be 3. A lot of functions will have the same gradient function. Okay, let's have a look. Find the general antiderivative of the following. Okay, the notation will be, I'll put that sign, 3x to the power 4 dx. Okay, you can leave this, well, I don't really like to leave the 3 out. I can just put 3 together with my calculation. It's just a times. It's just a times. So what I can do is 3x to the power 5. I will increase the power by 1. Right? I will increase the power by 1 because I reduced, well, I times the power in front and then reduce the power by 1. Therefore, now I need to increase the power by 1 and then divide by the power. So what I need to divide is the 5, not the 4. What I need to divide is the 5, not the 4. Why not the 4? Because that's after you reduce the power. What you times originally is you times with the original 5. Okay? So 5 is my original. And remember, you need to plus c at the back. After you get rid of the integral sign, you must have the plus c there. After you get, like, which line your integral disappeared, at that line, you need to have the plus c. Okay, at that line, you need to have the plus c. So what you have is 3 on 5, x to the power 5, and then plus c. Okay, for your integral instruction, is 2 parts. Okay, you can never left the dx out. You can never just without, like, students always forget the dx. In a sec like that, again, was 1 mark. Okay, you must have the dx at the back. Well, it's not always dx. It depends on what is the variable inside your function. The variable, if it's t, then you will say dt. If the variable is a, you say dA. Like it's changing with the variables inside. Okay, it's not always dx. Well, most of the time will be dx because we use x to represent the function a lot. But it will change together with the original like variables. Okay, how you can check whether you have a correct integral or not? How you can check that? How you can check if we have a correct answer or not after we differentiate that? Or anti-diff. We can diff back to see if we have that one. Okay, we can differentiate back to see if you have that one. Well, you should have the same one because that's the gradient function of that. Then you differentiate, we must have that. So I have a check. Times 5, we have 3, and then reduce the power by 1, we have the 4. So that's 3x to the power 4. That's correct. Okay? Someone just keep talking. Let's stop, please. Okay, have a look at the next one. 3x cubed plus that. So while they plus together, I'll separately anti-diff them and then plus them together again. So we'll anti-diff that. Well, normally when we have a number times in front, I'll leave the fraction out because it's hard for my calculation. Well, the first one, I'll have 3x. Well, I will increase my power by 1, which is 4, and then divide by the power. Plus, well, I'll put the 3 on 7 outside first. And I'll times x to the power 4, and I'll directly divide by 4. I'll normally write that in the fraction form because it's easy for me to look at it. Well, I'll directly divide the number below the x. So I'll divide that by 4. Plus 1 is same as plus 1x. Okay, plus 1 is same as plus 1x. Yep. Which was? Oh, sorry, that's a square. Yeah, thank you. That's a 3 then, and then I'll divide by 3. And then we have 1, which is plus x. And then the integral disappeared from the previous line to this line. Then I need to plus a c. Well, not necessarily c, it can be anything. Actually, it just can be d, can be e, whatever you like, but like better write c because c represents constant. Well, why we put c, not a, not b? Because it's constant. The c means constant. So you just plus a c there. So simplify that a little bit. 3 on 4, x to the power 4, plus 1 on 7, x to the power 3, plus x, plus c. Okay. Do not forget that c. Okay, c is very important. I will put you on later. Okay, so we have next one. Okay. Next one, we need to expand it first because it's times, again, integral fx times gx is not the same as integral fx and then times integral of gx. Like you can't do that when you do differentiation. Then you can't do that when you do anti-diff. Okay, so you can only do like separate plus or minus. But if you integral fx times gx dx is not equivalent to you integral fx first and then times integral of gx. Okay, they are not equal. Okay, they are not equal. So you can't do that. You don't need to copy that. Okay, just only plus or minus works. Others won't work. Okay, so I need to expand it to make it plus minus form. Plus minus form. So I can expand. That's x squared plus 1. X squared plus 1. So it is same as you integral x squared plus 1 dx. So I'll have x to the power of 3 divide by 3 directly, and then I have 1. That's the same as plus x. Integral disappear now. I need to have the plus c. Okay, I need to have the plus c. Okay, what you could do to that question if you want to integrate that? Well, that is not equals to increase the power by 1 and then divide by the power. Alright, you have something, it's not an x, okay? This is not a single x. You can only deal with a single x. Well, what you can do now is expanding and then integral. Okay, expanding and integral. But in year 12, well, not sure if you learned this chapter this year. Last year we didn't learn it. But there's a rule called chain rule. You can directly antidiff that. You can directly antidiff that. I don't want to confuse you now, like I haven't learned that properly. So let's just, well, I can go through that with you. I can go through that. So just remember, that's a part of the chain rule. You can just write down this formula. If fx equals to ax plus b, it must be a linear, okay? It must be a linear inside. If fx equals to ax plus b, then f dash x equals to what? Okay, f dash x will equals to n. Okay, first of all, bring the power down. It's quite similar to you deal with x to the power of n. And times something, times a, which is the gradient inside. You need to diff the inside function again. And then you have ax plus b to the power of n minus 1. Well, it's really pretty much the same. You times the power in front, you reduce the power by 1, but besides that, you need the extra component, which is the gradient a inside. Well, you can't seem as like I do nothing to inside. There must be something done with the inside. Well, then what's the difference between x to the power of n and ax plus b to the power of n? So the inside must be differentiated once. So which is the a? If you differentiate the linear inside, you have that a. So basically that's just a formula. So it's a times n ax plus b n minus 1. Okay, so that's the answer. That's the diff part. So if you go anti-diff part, if you anti-diff ax plus b to the power of n dx, that is the same as ax plus b. Well, I will increase the power by 1. And I will divide by the power, like this, the same as x to the power of n. But remember, before you will times the a in front, now you need to divide that a down. Well, originally you times the a. You can see that a, in the differentiation, you times the gradient. Now you need to divide by that gradient. And then all the same, like reduce the power by 1, then you need to go up the power by 1. You times the power in the front, you will divide the power down. Okay, so that is the formula for it. We can use different ways of doing this question. Therefore, we want to antidiff 2t minus 3 cubed, well, dt here. Okay, dt here. It's not a dx, it will be a dt. What you do is 2t minus 3, increase the power by 1, you have the 4. Well, you need to immediately divide by that power. Divide by that power. But it's not enough. You still have a linear representation here. It's not a t. If it's a single t, that's it. But it's not a single t. You need to divide the 2 again. Okay, you need to divide the 2 again. And plus c. Never forget the plus c. Every time you get rid of the integral, you need to have the plus c. So what you have is 1/8. 2t minus 3 to the power of 4 plus c. Okay, it's a really nice expression. Okay, it's a really nice expression. But the next method we use is not that nice. I need to integrate that, but I said, what you know now is by expanding. I can't do that. Well, if it doesn't tell you this formula, you can't do it, you need to expand it. What you need to have is xt cubed minus 3 4t squared times 3 plus 3 times 2t times 9 minus 27 dx. Minus 3 times 4a squared b plus 3ab squared minus b cubed and dt. So same as I want to integral 8t cubed minus, well, 9 36t squared plus 54t minus 27 and then dt. That is 4 divided by 4 minus 36t cubed divided by 3 plus 54t squared divided by 2 minus 27t plus c. Right, increase the power by 1, divide the power directly. What you have is 2t power 4 minus 12t cubed plus 27t squared minus 27t plus c. Okay, that's the method you do now. If you don't remember the x plus b to the power of n formula, you will go through that way. Well, think about it's a cubic, then yes, it's quite easy to do. How about if it's a power of 10 or power of 5? Like, it will be very hard to deal with. So it can't expand. So you must use that formula. It's not, you can't avoid it, but we're not learning it now. So what we'll do is only to the power of 3, and you can still expand, and you can do like that. Well, it looks a little bit different for both answers, but when you expand it, you have the same answer. Okay, when you expand, you have the same answer. Okay, that's D. Let's have a look at E. E is integral 3x to the power of negative 4 minus x to the power of half. I must write in the power form. Like the negative indices below the, like on the denominator, square root, they're not good. Okay, I must put them all in the indices form. So what I will have, okay, why I like to write things in the fraction form, because I can see where's my negative easily. So for example, this one, that's 3x to the power of like plus 1, you have negative 3. And then you will directly divide by negative 3. Well, things will look really clear, okay? The thing will look really clear. And you have that. Minus x to the power of half. What is half? Half plus 1 is 3 over 2. I will divide by 3 over 2 here. I'll still write in the fraction form. Because the integral sign disappeared, I will have the plus c at the back. Okay, for the first one, what I have is a minus x to the power of minus 3. For this one, you have a minus. Well, what I need to do is a fraction over fraction, which is not good. I will times 2 on both top and bottom. What I will have is a 2 over 3, x to the power of 3 over 2, and plus c. Well, I can write that into minus 1 over x to the power of cube minus 2x 3 over 2 over 3 plus c. Well, don't really need to change. The second last line is good enough. Second last line is good enough. Okay, so you want to change everything into index form. Okay, everything into index form. Okay, next one looks a little bit complex. Well, it's exactly same as what you do for differentiation. Before, when you see a single thing at the bottom, you will separate them. So what you do is 4x a quarter divided by x a half minus 4x a half divided by x to the power of a half plus 3x to the power of negative 2 on 3 over x to the power of a half. What I have here is 4x to the power of negative a half. Okay, a quarter minus a half is negative a half. What I have here is a minus 4. What I have here is 3 plus x to the power of, okay, negative 2/3 minus a half. Negative 4 on 6 minus 6 on 3 on 6. So that is a minus 7 over 6. It's a minus 7 over 6. So I want to integral that. I want to find the integral of that. Okay, what I'll do is plus the power by 1. I'll have half. And then at the same time, I need to divide by a half. 4 becomes 4x. Okay, no doubt. It's a constant, directly add the x on. Plus 3x to the power of, well, negative 7 over 6, you plus 1, it's just become negative 1 on 6. Right? 7 on 6 plus 6 on 6 is minus 1 on 6. Minus 7 on 6 plus 6 on 6 is minus 1 on 6. And then I will divide by minus 1 on 6. Plus c. Okay, plus c. Always tell yourself plus c, plus c, plus c for antidiff. What I'll have is 8. X to the power of half minus 4x. Okay, minus 18. X to the power of negative a quarter, and then plus c. You times 6 on top and bottom, that give you a minus 18. Minus 18. Okay, any questions about that? That's just a purely like formula. We just keep using the formula. Okay, so that's anti-differentiation. This is called the indefinite integrals, and it is called the, like you find general derivatives, you will have the plus c at the back. Okay, plus c. Just say that 3 times. We'll do antidiff. Okay. Yep. Not for the test. It's just for later on, like extension a little bit. Okay, example 2. Okay, example 2 will be good. Why is good? Let's have a look at this question. F dash x is that's a plus. Okay, that's a plus. X to the power of 3 plus 4x squared, and you have f0 equals, well, f0 equals to 1. Well, why I'm missing so many things? Oh, just must be something wrong when I type it. Well, let's say f dash x is x cubed plus 4x squared, and f0 equals to 1. f0 equals to 1. Find fx. Okay, find fx. So this is an example tells you how to find the c. How to find the c. So what we should do is, well, f dash x equals to that. Fx must be equals to integral of that. Because to differentiate fx, you have f dash x. Now you antidiff fx, you must have antidiff f dash x, you must have fx. So fx equals to x to the power of 4 divided by 4 plus 4x to the power of 3 divided by 3 plus c. You always have that plus c. Okay, always have that plus c. And what you know now? You know f0 equals to 1. What is f0? f0 is 0 over 4 plus 4 times 0 over 3 plus c. f0 equals to 1. What that tells you is c equals to 1. Okay, give you a point can help you, like 1 point is enough. 1 point can help you to make sure where is the function. Okay, that can tells you that c value. So fx equals to a quarter that and plus 1. Okay, now you can work out the c. You don't need to leave the c there. You can actually work out the c values by a point passed through the graph. Well, the graph passed through a point, and then that c can be worked out by that way, by substitute the point in. Well, by giving you x, y values, you can find the c value. So c is 1 in this question. Okay, have a look at the next one. Suppose that a point moves along some unknown curve y equals fx. Well, don't worry what does the point means. It's just like you have a curve fx. Okay? And in such way that each point xy on the curve, the tangent line has slope. Okay. Keyword is here. The tangent line has slope. Okay. Slope is gradient, right? What's the notation for gradient of the tangent? What is gradient of the tangent? Use a math symbol. What is it? What's the gradient of the tangent means? What is it? dy dx. Okay, you must remember that. The gradient of the tangent is the dy dx. Well, slope is the same as the gradient. So it's f dash x, because we use fx in this question. So it's f dash x is 1 over x squared. Well, what the whole sentence is talking about is f dash x equals to 1 over x squared. How you can know that? You must know that f dash x is the gradient of the tangent. Okay, it's the slope of the tangent. Slope of the tangent, gradient of the tangent must be dy dx, and that will be all f dash x. It depends on what you have. And then we have that. Therefore, I know my fx must be integral of x to the power of negative 2 dx. Then fx equals to x to the power of negative 1 over negative 1 plus c. Make it look beautiful. That's minus 1 over x plus c. Because I have the minus, and that x minus 1, power of minus 1 is 1 over x. So it's minus 1 over x plus c. Given that it passed through the point 1, 3, so f1 equals to 3. So 3 equals to minus 1 over 1 plus c. So 3 equals to minus 1 plus c, c equals to 4. So fx equals to minus 1 over x plus 4. There is a restriction. Okay, there is a restriction. Just go up. For this formula here, there's a restriction. N can belong to any value r, but just except negative 1. You can't have negative 1. Why you can't have like negative 1? Because when it is negative 1, it's not a polynomial function. It's actually a logarithm graph. But like we're not talking about that yet. But why can't be negative 1? Because what you're trying to divide is n plus 1, right? If n is -1, -1 plus 1 is what? It's 0. It doesn't work, okay? It's not because like what other graph I can have. It's because this formula cannot work. So n cannot be -1 here because -1 cannot give you a valid denominator. So it's a 0 denominator. That doesn't work. I can't have -1. N can be any other things, just not -1. Just one thing not work. Well, if you really have -1 and then you try it, you can see that doesn't work because you will divide the 0 in the end. Okay. Just have the last one. The last one says the curve for dy dx is that where k is a constant in such that the tangent at 3,6 passes through the origin. Okay, the tangent at 3,6 passes through the origin. Find the gradient of the tangent, hence determine the value of k. And of this equation, okay. Such that the tangent, okay. Let's just have a think. I have a tangent line at 3,6. Let's go things one by one. Okay, let's do things one by one. First of all, I have dy dx equals to 2x plus k. I have 2x plus k. So the gradient at 3,6, let's say we have the point 3,6. Okay, the point 3,6 is here. Let's say whatever, I have a curve. Okay, I have a curve passes through 3,6. And I have the gradient of the tangent passes through the origin. So there must be a line passes through origin. Well, let's say my curve could be that. So this is the gradient of the tangent. That's the tangent line. And the tangent line passes through the origin. So can you tell me what's the gradient of this graph? Now what's the gradient of this tangent? That point is 3,6. And also you know that it passed through 0, 0. What's the gradient? 2. 6 minus 0 divided by 3 minus 0. The gradient equals to 2. What that tells you is when x equals to 3, dy dx equals to 2, right? dy dx means the gradient of the tangent. At the point 3, you have a gradient of 2. So when x equals to 3, dy dx equals to 2. So 2 equals to 2 times 3 plus k. K equals 2 minus 4. K equals to minus 4. So dy dx equals to 2x minus 4. Well, what I need is I need to find the k. So that sentence, well, it's a hard question. That sentence tells me the gradient of the tangent at that point. So y equals to integral 2x minus 4 dx. That gives me x squared minus 4x plus c. Okay, you know that is x squared, right? You have a 2 and then you divide by a 2. That's x squared minus 4x plus c. How we can find c? We know that 3,6 is on the curve because it's the tangent at the point 3,6. 3,6 must be on the curve. X equals to 3, y must be 6. Well, 3,6 not only tells us the gradient of the tangent, it also tells us an original point on the graph. So 6 equals to 9 minus 12 plus c. 6 equals to minus 3 plus c. C equals to 9. So y equals to x squared minus 4x plus 9. X squared minus 4x plus 9. How I can find k first and then how we can find the c. Okay, that's how we do that. We just finished this chapter.